In Creo Parametric and Creo Simulate, we can take advantage of symmetry in our models in order to get our analyses to run faster. Here I have a very complex model that I want to analyze in Creo Simulate. It's got a lot of features in it, a lot of small surfaces, and I know that this is going to generate a very complex mesh. But I take a look at it and realize that I have a plane of symmetry. Therefore, I can create a cut in my model to remove half of this, and I'll end up with half as many elements, and it will run significantly faster. To create my cut, I'm going to turn on my datum plane visibility, and in another video, I showed a shortcut of how to create a cut using a datum plane. I'll select this datum plane and then click on the solidify command on the model tab. And this model is so complex, it's even going to take a few seconds to compute this. And there you can see that it's showing that it's going to remove half of the geometry from my model. That's good. Let's hit the check mark or middle mouse button. And I've removed half of the geometry. Let's turn off the datum plane display. Now I can go into Creo Simulate in order to set up my symmetry constraint. Let's go to Applications and then Simulate. Now I am in Creo Simulate. You can see that this model already had some loads and constraints in it. And be aware that you can only take advantage of constraints if everything in the analysis is symmetric. If your material properties are symmetric, if your loads are symmetric, and your constraints are symmetric. To let Creo Simulate know that this is only half of the model, I have to add a symmetry constraint. To get to that, you go to the Constraints dropdown, and here you see Symmetry. Here we have the Symmetry Constraint dialog box. You can change the name if you want. I'm going to leave this as a member of my set that I already have in the model. Here's the type drop-down list, and you can change between mirror and cyclic. This is mirror symmetry. And for the references, let's select this particular surface in the model, and then click the OK button. And there you can see an indication on the computer screen of the symmetry constraint that you have. And if you want to make changes to it, you can select it, and then from the mini toolbar, choose Edit Definition. And here you can see it is, oh wait, that's actually the hard point control. Let me cancel out of that. Let me go to the model tree, a little easier to select it. And I can select Constraint 2 here and hit Edit Definition. And here we have the Symmetry Constraint dialog box. Essentially, in the old days, back when you were doing finite element analysis, you would set up constraints that would basically remove some of the displacements and also some of the rotations of the different nodes in a model. But this symmetry constraint does all of that for you. So this is good for defining the mirror constraint. Let's take a look at doing a cyclical symmetry constraint. So here I have a model of a fan turbine blade, and I happen to know that there are 18, well, I counted them. There are 18 different blades in here, and it's got cyclical symmetry. So this would take a long time to run if I just left the model as is. But in my particular situation, I know that I have rotational symmetry, my constraints, my materials, my loads are all cyclically symmetrical. So let's take advantage of that. I'm going to start off in this case by creating a sketch in order to make a cut. Let's sketch on this surface, and let me turn on my datum plane visibility because I want the datum plane called top to face the right side of the computer screen. And again, I'm setting up my orientation reference, so I automatically get a sketch reference there. Let me turn off my plane display in order to unclutter my screen. And let me click on the icon in the quick access toolbar to go to my sketch view. You can see even reorienting the model took a while there just because it is so complex. Let's throw in a center line, a vertical center line, and I want that because I know that I'm going to throw in a constraint in a moment. And for my sketch, I'm just going to sketch in line over here, it's not snapping symmetry. That's okay. I'll throw in a constraint in a moment. So that is good for my sketch. Let's go to our constraints, and I want it this horizontal line to be symmetric about that. And let's throw in a couple of dimensions. I mentioned that there are 18 blades in here, so I'm going to create this at an angle of 20 degrees. And let's throw in another dimension. I just want to make sure that this is going to be big enough to cut through my model. Now let's change that to a value of 10. That is good. Let me hit the middle mouse button to get out of dimensioning mode. I will hold down the right mouse button to get to my pop-up menu, which allows me to click the check mark to save my sketch and exit out of sketch mode. Now I am back in part mode. Let me rotate this around here, just get at a bit of an angle. And with the sketch still selected, I'm going to click on the extrude tool. This wants to add material to my model. Let me flip the direction of the feature and hold down the right mouse button. I'm going to change the depth to through all, which does not make sense for an extrude. So let us hold down the right mouse button, and from the mini toolbar, I'm going to choose that I want to remove material. And here it is removing one of the blades. If you click on this icon, it'll flip the direction of the material removal. Or you can hold down the right mouse button and you can toggle the material side to the outside as well. It does the same thing. And that way you can see that I have much less geometry in here. I've removed 17 out of 18 of the blades. Let's hit the check mark or the middle mouse button to complete the feature. And so again, you can see that, yeah, it doesn't even look like this is just a sliver. You're like, hey, that extrude must be wrong, but no, it is correct. Now let's go over to Creo Simulate. I will go to Applications and then Simulate. And again, this model already had a material assigned and already had some loads like the centrifugal load, and it's already got a displacement constraint for that center hole. In order to take advantage of cyclical symmetry, let's again go to the Constraints Overflow menu and then click on the Symmetry command. And here we have our symmetry constraint. Again, you can change the name if you want. Maybe I want to call this cyclical, if I can spell cyclical today. And it's going to be a member of constraint set 1. And instead of mirror, this time I'm going to go to the drop-down list and change this to cyclic. And so for my references, you're going to pick one side of the model, like this surface over here, and then pick the other side of the model. Oops, I forgot to activate the other collector. You can click in that. And now we can select this surface over here. That is good. I will click the OK button. And there you can see that there was a note on the screen. Let me go back to it over here. Here's my cyclical constraint and says that the name of the constraint is cyclical and it's 20 degrees of symmetry. So again, this is going to end up creating a much less complex mesh and it's going to run a whole lot faster. So again, if you have that particular situation where your geometry, material properties, loads, and constraints have symmetry, take advantage of it in order to get the model to run faster. Now be aware that this ended up creating features in the model in order to remove the material, so you might want to use part simplified reps or maybe an inheritance feature in order to avoid making changes to the original design model. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.